Welcome back. So, what we are going to do in this hour is slightly different from what we have done so far. So far, we have been understanding the concepts, what is data analysis. We are going to apply it to some concrete problems now, and I want you to understand how to process an analysis. How do you go about solving a problem? And I will also show a dashboard. So this is about hands-on discussion, and I will show one of the tools called cowiz++. Okay, so most of these are I give as class projects to students in my class, and they come up with different solutions, and then we evaluate them based upon how good they do. So first one is the census data analysis. So we have a 1990 census data with over 32,000 rows. This is by no means a very large data set. The original data has already been pre-processed as follows. So this is important. Pre-processing of data is an integral part of data analysis. Discretize gross income into two ranges, 50K and less than 50K. Converted U.S. into US to avoid periods. Converted unknown to question mark. Sample input. So here is the data. So this is one row of data, comma separated. I'll explain what each one is. This is another row of data, comma separated. So you can see that the last attribute is either it says less than 50K or greater than 50K. Now this has been pre-processed and added. Now that makes it a label. So you have a lot of attributes. In fact, you can take this data and create a decision tree if you want and do cross-validation and then check the accuracy of the model. But that's not what we are going to do. So you also need, remember I differentiated between data and information. Just looking at 32 private, some number, SH grad doesn't help. So here is the description of the data. So each column, so maybe I should have put one of them. So working class, FNL weight, that is a continuous variable, education number, marital status, occupation, relationship, race, sex, capital gain, capital loss, and then the last one is the hours per week, native country. So these are the description of the data. So this is the description of this data. You can see the last attribute is United States, that is the country. In the second one, it is unknown. There is no value for that information. And then you have married, professional, specialty, whether somebody is a high school graduate, whether somebody is a husband or a wife, female, white, male, so on and so forth. So this is the data description. So what do we want to do with this data? Here are the three analyses that we want to do. These are fairly simple, but I want to show that analysis can go from very simple to quite complex ones. Count the number of people in the following age groups: less than 20, 21 to 40, 41 to 60, greater than 61. This is what is known as a histogram. So plotting groups over a range is the notion of a histogram. Analysis 2, for the above age groups, find the number of people in each of the following professions, whether they are working in private, self-employed, government, without pay. Draw a separate pie chart for each group. So this is something like a drill down. You first get a higher level value and then you drill down further to understand more details. The third one is identify top 5 occupations for the entire population. So what are the most sought after or occupations that we see in that data analysis? So this is the problem and the analysis. So while looping or separately count the number of people in each occupation, sort it, and choose the top 5 occupation categories. All 3 analyses belong to the descriptive class. Remember, descriptive and prescriptive I talked about, because this is more of the descriptive analysis. So I have some Python code and other things. Perhaps I won't go over that in more detail, but I will just go over the steps. So data is uploaded into so we use Google Colab for certain data analysis. Sometimes we also use Jupyter Notebook. We also use just RStudio or Python. So depending upon what you are comfortable with, what is appropriate for what we want to do. So we use it. So data upload. So data upload is the first step. And I will skip so it's a CSV file. You can use the code. Pre-processing is done to remove rows which contain question mark in their columns, and this can be performed using the pandas library, and random sampling is done to get there. So what I typically tell them is to do the sanity check for a small sample like 300 records. Make sure what they are doing is correct, and then apply it for the larger data set. Panda library Python is used for processing manipulation of the data on matplotlib library is used for visualization. By iterating the entire pandas data frame using itros function for the pandas, then you can classify or count the number of people in each of these age group, use nested if, else if conditions each for the former, and so on and so forth. Okay, so this is fairly straightforward. So here is the first analysis result. So here you can see that you can get this is why I say visualization is important. Instead of just giving numbers in a table or some such thing, so here you can clearly see that majority of the people are in the age group 21 to 40. And that's very clear. And there is a small number of people in the age group 20, less than 20, and see the other end. This one is fairly far. Okay. So this is the first analysis. So second analysis is to drill down and create pie charts. So again, there are libraries for doing it. I won't go into the details of how it is done. There is code for any of those who are interested in that. But what I want to show is the result. So here we have pie charts for age group less than 20, for age group 21 to 40, age group 41 to 60. So this is very important. I want you to clearly understand what this means, what this analysis means. You can see that younger people in the age group less than 20 are in private jobs, 90.5%. As they age, that becomes 75.4%, then it becomes 65.4%, and it becomes 58. What does it mean? You know, at an younger age, you are willing to take more risks. You are willing to join startups, you are willing to take risks, but as you settle down, you want to make sure things are more stable. And you can clearly see in the population data what kind of job people take, different age groups varies over the age group. So this is the important thing. This is what you need to understand, not just the numbers, the trend or how things. Similarly, you can see that very few people are in the government or without pay, and that pink slice keeps increasing. So And then the last one is self-employed. And again, you can see that less people are self-employed, 3.8%, obviously. And in the last one, 25% are self-employed. So this is what you really need to understand from the analysis, not just the numbers. And without visualization, it is somewhat difficult to comprehend. That's why I keep saying drill down and visualization, why they are important, because this kind of information is difficult to obtain even with the results if you don't have the right representation to show it. Okay, any questions? This is for this data. If you take a different data set from a different country, it may show something different. So you can compare countries, or you can take states within a country and then compare them. So if somebody wants to know which state prefers what kind of jobs in what age groups, you can do this analysis. Very easy, very simple, very easy to understand. Okay? Finally, the top 5 occupations are relative. While doing these things, you can count. So here is one way of showing that. Professional and specialty occupation, large number of people, then comes craft repair, then comes executive managerial, administrative clerical, and sales. So this is one way of representing it. Another way of representing it is what we call the word cloud. I don't know, you must be familiar with the notion of a word cloud. Word cloud is very commonly used for this kind of things. What word cloud means is all the categories are shown, but the size of the fonts indicate which one is bigger compared to the other one. So you can see here that professional specialty has the biggest one, then executive managerial. So this is another way to understand things visually in a nicer way rather than using numbers. So this is also very important. Okay. That's one set of descriptive analysis. So let us take a look at prescriptive analysis. What kind of things we want to do for prescriptive analysis. So this is a more involved problem. So you are given a large airlines data set indicating the flights operated by many airlines. We have replaced the airline name we have anonymized the airline name, L1, L2, etc. It has about 6,700 routes of several international and US carriers. The data set contains the following information in each line. So this is the, so this is the description of that airline. So what is important to this, AL242 is the airline, anonymized airline. So part of the problem is to identify 2 airlines. Pick 2, L1 and L2, and identify possibly which airlines are there. And then there is the airport code for the starting airport, airport code for the ending airport. There is more. Then there is the open flights identifier, destination airport ID, code share, whether this is a code share flight or not a code share flight. A lot of times different airlines do code share flights. And then stops, number of stops on this flight. In this example, all of them are 0. That means they're all non-stop flights. And finally, the type of carrier that is used. Now, I have asked him to do some kind of analysis on this data set, but you can do various kinds of analysis on this database for various needs. So analysis. Analyze 2 specified airlines. In our case, we have chosen AL1 and AL3. Construct a graph or a graph data structure. So we have studied graph today. Hopefully it is still fresh in your memory. Before you forget, I wanted to give this. If I give it tomorrow, maybe you don't even remember what it is all about. So what we normally do is I give different parameters to different groups because they will all copy and give me the same answer. So I give different airlines for different teams so that they cannot copy. If they copy, the answers will be wrong. So generate characteristics for this airline route graph. This will help understand some of the characteristics of the data set you are analyzing, interpret them from an airline's operation perspective, and find the top 3 to 5 nodes from where there are more flights than others from the airline. These are terms hubs by the airline. You can use a node centrality detection algorithm that we have discussed today. Once you have the top K hubs, try to identify the airline that you are working on. You can use any data that is available on the internet for this purpose. We will give you a file that maps airport codes to airport names and cities. This is also very important. So why I am showing this is many times the data by itself may not be sufficient for every kind of analysis you want to do. So you may have to augment information on that data from multiple sources. And you should understand what sources are reliable, what sources you want to augment information from, and how to use them. That is part of the overall analysis. In the next step of the analysis, your goal is to identify or predict the next hub for airline expansion. For this, you can use demographic and other information that is available on the internet. So this is predictive because if the airlines are always looking for how to expand, what should be our next hub, and how do they decide that? They have to have some way of looking at it, determining how to do that. Sometimes their bet may be good, sometimes their prediction may be wrong. All of this is possible. Okay, approach. After cleaning the project, separate your airlines from the data set because this has about 200 different airlines. We are only interested in 2 airlines that are given to us. Run degree centrality algorithm to find the degrees associated with each airport. So here comes mapping. If you want to find airline hubs, what analysis do you need? Do you need degree-based analysis? Do you need okay. So run degree centrality algorithm to find the degree associated with it. Use the top 5 to identify the airports and the airline using internet and other sources. For the next hub, use the next 3 airports. So you have a list of airports, some of them are hubs, some of them are non-hubs. First step is to which ones do you consider among them. So that should have more centrality to start with. Using them, determine which one would be better as the next hub. Other business related information can also be used if available. So Python code, the Python package network X is used for this purpose. Here we have to predict what the airlines AL1 and AL3. Read data set, so I'll skip over this. I'm sure you're all familiar with it. So here is the output. You can see that this graph is not very large, but still it is difficult to fully understand the entire graph. Again, you can use real visualization, interactive visualization to look at it. So you can clearly see why this is an airline network. You have endpoints, like airlines fly from hub to points and then back. There are multiple hubs, they also fly. So you have multiple hubs and then you fly to different places from that. That's what this looks like. So again, you can look at the same thing. You can look at the same thing and map it as a world cloud. This is a little bit easier to understand. Now remember, we gave the mappings for the cities and this one. So you can see that DFW comes out to be the largest hub. That means there are maximum number of flights from DFW. That happens to be Dallas, Fort Worth, where I live. Then you have Miami, CLT, Charlotte, Phoenix, WARD is Chicago, JFK, LAX is Los Angeles. You can see this. You can see, so from this, you may not be able to guess it, but I can easily guess what airlines this is. Because I know which airlines has, DFW is the hub of which airlines, and that is the American Airlines. So this airlines is the flight schedule for American Airlines. So it is easily derivable from this. So the second airline, so that has a different set of things. You see that it has two connected components, two things rather than one thing. And again, this view is not very useful. Again, we go to the world cloud view to understand this better. Now this shows a different set of airports. ATL is the Atlanta airport, and MSP is the Mississippi airport, JFK, Salt Lake City, and so on and so forth, CVG. From this, it's very easy to infer that this is Delta Airlines. Delta Airlines has its hub in Atlanta. American has its hub. So you are able to identify the airline based upon your analysis. It was purposely we masked it so that students exercise some inference to do so. So what are the characteristics of the first airline? Number of nodes, 434. Number of edges, 1191. Diameter of the graph, remember we talked about all of this earlier. Density of the graph, point. Components of the graph, degree of the graph. So each node has a different degree and it varies for the different nodes in the graph. Average degree node of the graph, 5.4. Minimum degree node of the graph, 1. Maximum degree node of the graph is 184. That means from this node there are 184 different outgoing flights. So characteristic of the second airline, number of nodes is different. So that was 100 something, this is 300 plus something. Number of edges is also more. Diameter is different. Density also is different, not the same. It has two components as we saw. Degree, average degree, minimum of degree of nodes, maximum of nodes. So we have all this information. Now we can sort. We can sort based upon the degree and see which ones come out as the top 5. So degree centrality refers to the total number of edges coming out from a node to destination nodes. In our context, refer to the number of destinations, airports to which a source airport is connected with by a given airline is given by degree centrality. high degree centrality simply refers to busier airport as more airlines are operating in that node. Function for finding the high degree centrality node is, this is a method from the package. So the airports with which the airline have more degree centrality can be determined as the hub. The following slides comprise the degree centrality information. So here is the output. Here is the airport, the degree centrality associated, either if this is a normalized degree, right? You can also use the, and the airport name. So you can see that Dallas Fort Worth is the topmost, Charlotte, O'Hare is the Chicago airport, and Miami International Airport, Philadelphia Airport, and LHR is the London Heathrow Airport, which is not in the United States, and the rest are all in the United States, Phoenix, Washington DC, and other things. So now you can look at this list and say which ones are already hubs, and look for ones that are not hubs, that are potential contenders to become the next hub. So that's what you need to understand. So in order to do that, we have to use additional information. The information that is given is not completely enough. So approach for predicting next step for American Airlines. The next hub for the American can be chosen from the 3 major airports with high degree centrality, which are not recently included in hub of the American Airlines, by comparing various things: education, income, and population. So I know the names. So I can look up the population for London, I can look up the population for Seattle, population for Boston, educational degree in percentage, how many, what percentage have bachelor's degree, because that also contributes to willingness or ability to fly. And then average income, per capita income in these cities, $58,000, $59,040. Similarly, the same analysis is done for Delta, and the one in blue are already chosen as the airlines, and then same thing you can also compute, Cincinnati, Orlando, and Amsterdam, and then say which one should be considered as the next airport. So typically this is the approach that is used by analysts to analyze different kinds of data from different domains and then figure out what is important for their business. Every business has a different need, different requirement, different objective they want to figure out. If it's an educational institution, they have a different need. They want to know where our students come from. Which state contributes to the maximum number of students, for example, or within a state, which region contributes to the maximum number of students? What is the income level in those regions, in those pin codes or zip codes? So there are different ways of analyzing things for different purposes. Okay? So as an analyst, you really need to have a broader understanding of, and also equipped with a broader set of tools. You cannot be an analyst just knowing one thing. That is known as the single pony trick. So you cannot be a single pony trick. And that is the only trick you have. You try to apply it to every problem, it's not going to work. Okay? Any questions? Do you think you could have solved these problems if it was given to you as a homework? That's what you have to ask. That is the test. If this problem was given to you, would you have solved it? If not, you have to ask why. What is that you are missing? And try to compensate for that. Okay? Okay, next. So this is very different. This uses communities. So this is a dashboard we started developing at the time of COVID. Now when COVID happened, everything, everywhere it happened, and we felt when we looked at various dashboards, they were only giving descriptive information, statistics. But we wanted to see whether we can do something beyond statistics, prescriptive information or much more understanding along with visualization. And we started this. This was developed by this team of undergraduates, 1, 2, 3, 4 undergraduates. Abhishek Santra was doing PhD at that time under me. So we decided we will try to do this. By the way, this one is publicly available and active on my website. You can go to this website and play with it. It's available 24/7. You can play with it. So, what are we trying to do? So, this is going to illustrate in more detail the difficulty in the data collection, pre-processing, consolidation, analysis, and visualization. So these are the steps. You have to first collect data. You have to do pre-processing. If data is coming from multiple sources, you have to consolidate. Then you have to do the analysis. Then you have to visualize. So these are the various steps. This is the life cycle, and I will try to explain some of them before going into the dashboard itself. So modeling, we use graphs and multi-layer networks. In this one, we use notion of community, but on a graph. Drill down, we use additional attributes to understand details. So drill down is very important because the data set may not have all the information. So for example, when you look at COVID data, they will say, this county, these many deaths, these many people who are taking in the hospital. But it doesn't tell you the population of the county, it doesn't tell you the education level of the county, it doesn't tell you the mobility of the county. All this have to be obtained from different sources. Visualization, we wanted to make COVID spread and other details easy for ordinary people to understand. So we developed the COVID dashboard, developed for providing understanding real-time and analysis. So this is real-time data. We were doing it in real time. We were collecting data in real time. So the data goes from 2020 to 2022 October. After that, there is no data feed from October 2022. So all the data between those two times are available. So you can think of two categories of analysis and visualization. First category we call visualization of base data. This requires little or no analysis required prior to visualization, primarily statistical information. For example, did the vaccination drive increase confidence among people to take more road trips? In states where low per capita income, how testing progressed? Was there a surge in the number of cases? Has the death rate reduced in countries where most of the population has received all vaccination doses? What about countries where the vaccination drive is slow? So this is true because in many places people did not want to take vaccination. In US that is true. Nearly 25% of the people refused to take vaccination. Second analysis is analyzing the data and visualizing it. Explicit analysis required for visualization. So here the analysis questions are very different. In which regions was vaccination most effective? So how do you find which regions of the US? We use only US because we were able to visualize it on the US map. Google doesn't provide other country maps for visualization in the same way as US map. So we use US map. Uh, that is, how have geographical regions with maximum and minimum rise in cases shifted between periods pre and post beginning of the vaccination drive? Which regions got significantly affected due to long weekends? So in US, we have these long holidays. We have July 4th holiday, we have Labor Day, we have Memorial Day, we have Thanksgiving. And what was seen is whenever we looked at the data before and after the holidays, there was a spike. Essentially, this meant that people were traveling, people were meeting each other more often, so spreading was much more prevalent than times when they were not doing it. So that can be seen. So how to analyze, drill down and visualize complex data. So multiple participants, entities, features and relationships. So we have, these are different kinds of data we have. Deaths, recoveries, hospitalizations, tests, vaccinations, demographics, locations, positive cases. So it is not a very simple analysis or a simple visualization. Single source versus multiple sources. So if you have data from a single source, just like that census data, it's very easy. One file, you can clean that file and do it. Whereas in the airlines example, we had to, that also had singer, but we will see another case tomorrow where we scrapped data from 6 airlines and then used it. Multiple sources, different information about the same entity provided by multiple sources. Example, for COVID tracking, multiple county level, state level and national level organizations are publishing data on the web. So what we wanted to do was to develop a modular architecture. This is always very important. I emphasize it. This is what we do in all our developments. You want your system to be modular in the sense extensible. It should be able to add a new module without having to change the entire system. That is extremely important. So we have the user interaction component. So the user interacts via a dashboard on the web, and the input goes to the middle layer, visualization management module. And in the visualization, it checks, has this question been already asked? If it has asked and we have the analysis for that, we will show the analysis. If the analysis is not there, so then we display it. So there is a input component and a visualization component. And there is. If the analysis is not there, we have to analyze. So the third is the data analysis. These are 3 independent modules. In fact, 3 different groups of people were working on it at the same time. Very little interaction between them. So it is localized. And in this one, as you can see, this is where we acquire data from the web. We acquire data, we pre-process it, and we do different analysis. So I've shown analysis 1, analysis n. So if you want to add a third analysis, you just add it to this portion, everything else remains the same. So you can modularly add additional analysis into the dashboard without much effort. Of course, there is some effort involved, but without tearing down the whole system. So this is extremely important to do. So, and then if you do the analysis, it comes there, and then you generate the visualization, and it is displayed. So this is our architecture. So here is a sample of category 1 analysis. Effect of full vaccination on the death rate. I'll show you the live demo, but this is just a sample. In this one, you can select some number of countries. Here it is India. What is the second one?
Israel. Israel.
And the United States. Now this panel shows people fully vaccinated. This panel shows new deaths. And you can see that the data starts from April 20 in this one, but I'll show more. So you can compare new deaths. You can see that for some reason, around this time, the new deaths increased significantly in India. It did not increase in Israel, it did not increase in United States. Whereas here, people fully vaccinated, it took a long time for people in India to get vaccinated. Whereas it was much more aggressive in other places. So you can see this very clearly, how things are happening using live data. So till June 21 in India, where only 3.19% of us fully vaccinated, the number of deaths had been on a rise and was more than the other better vaccinated nations, USA 40% and Israel 59%. So this is what is borne out by the actual data collected on this one. So analyzing the impact of events. So this is perhaps we consider the most important, which uses the notion of a community. So what we want to do is, we want to analyze and see how COVID cases changed before Thanksgiving and after Thanksgiving. Was there an increase because of the holidays? It's a 5-day holiday, perhaps the longest holiday in the US, and it has people get together, families get together. So we designed this to include two things. There is a base period prior to the event, number of new cases from the basis for comparison. So for example, November 10th to November 19, 10 days. So this is the interval, this is the base period. Then you take a target period which is after the event. So Thanksgiving comes in the 4th Thursday of November. So Thanksgiving falls in between November 19th and December 3rd. And then we want to look at the target period for the same 10 days period after the event, number of new cases compared against the target period. So equal period lengths. What we have done is, so United States has about 3,700 counties. 3,700 countries will be used as nodes. And then we construct a graph. An edge exists if counties have similar percentage change in the number of new cases in the target period before and after. So county communities, so compute communities in this one and then plot it on a map. So the severity level is, I cannot read it, you may be able to read, so there are levels. Is the increase, has it decreased? Has it remained neutral? Has it increased or further increased or just spiked? So green versus red. And this is what we show to the people. You can see from this clear which regions of the United States increased. Red is the highest, right? Increased over this holiday. Which communities in green did not change or decreased. So this is a very visual understanding of what is happening for the entire country. This is very difficult or even impossible to show in numbers. That's why we are using a map to map it. We will show a little bit later. So the detailed architecture, if anybody is interested, I won't go into the details. So there are a lot of pieces for this architecture, how we read data from external sources, how we pre-process, how we consolidate. It's a long process. So here is another view of lockdown in most countries, most counties. So April 1 to April 30 base period. So in there was, every state was doing something differently. Some states refused to do lockdown, some states wanted to do lockdown, so the effect was very different. In lockdown states, the COVID rate increase was very small. Where there was no lockdown, it was very high. So there were a lot of things playing on, but this shows you which regions of the country are affected more than which other regions, to what extent. So this is target period June 1 to June 30, 2020. This is target period May 1 to May 30. You can see the difference between these two. You see, there is a lot of green here. There's a lot of red here. That means all the green things have spread COVID into those regions, and now they are showing high incidence of COVID compared to 1 month ago, May and June. This is July 1 to July 30. It's even worse. The entire country looks bad. And then this is August 1. So these are snapshots. This is bad. October 1 to October 20, except the northeast corner and few pockets, the entire country has high incidence of COVID. This is even worse. So perhaps this is the peak. Maybe this is the peak. Okay. New 2022 New Year holiday break effects. So here are two comparisons just to show that 2022 New Year holiday break effect in the US. Before holiday, after holiday. Okay? So you can see this is from December 13 to December 17th versus December 18 to December 22. Post New Year, January 5th to 9th versus January 10 to 13th. So this is also the drill run. So we have added additional information for each county. If you hover over a county, you can see, I cannot read it, but population and education level, so on and so forth, you can read. So reports attributed this massive surge to the widespread travel to popular tourist destinations during the break, leading to crowds and non-adherence of social distancing norms at the time when the Omicron, that is second variant or third variant, was becoming dominant. So, sort of that gives you an understanding of what it is. So where do we get our data? CDC, OWID, US Department of Transport, daily mobility reports from Google, other sources, restaurant occupancy, census, daily tweets, spending categories. These are the different sources. So I just want to make you understand, data analysis is not easy. It requires a lot of thinking, a lot of ideas, and to do it properly. Okay? So data pre-processing challenges. Formats. Delimiter, it can be a comma in one. Data, it can be a tab in another one. Numeric data, test data, location data, latitude, longitude. Date format is different from different sources. One is MMDD YYMMDD, temperature, Celsius, Fahrenheit, measurement units, name. You use 2-letter code, sometimes you read 5-letter code, you use FIPS code. Missing attribute values. For multiple input files based on which common column attributes, this is equivalent to the join of a relation, which columns to shortlist, what are the interesting features. So this is what we do. So we take data from different sources and we extract the common key plus other relevant values for that particular thing from multiple sources, so that we have one file from which we can use all the values to play with. So that is what we get at the end. So I won't go into the details. So this is what the files look like. Need for configuration files, so we use configuration files. I think I'll skip that. Sample merged COVID data file. Static versus dynamic data. This is also very important. So we did both. So the issue was when we were developing it, data was coming in every day. So every day the data was updated. So we had to read the data incrementally for that day and merge it with the existing data so that it becomes part of the visualization, part of the analysis. And that's so we had cron jobs running in the middle of the night, sometimes 3 times a day, to read data up to that point and merge it with the thing in the background. Everything automated. We were not doing it in manually. And then using that data. Automated web crawl to collect data updates, parameterized on demand call to external APIs, asynchronous. So we also were, now it is not there. At that time, we were also reading the Twitter data dynamically. If you say a particular period, we would grab the Twitter data for that period and show it in the dashboard. So let's go to the where did I show the link? I think I have the link here. Let me. Oh. It doesn't. Okay. I don't know what I did with the link. Okay, let's go to Google. This is our website. You can see here we have 3 different dashboards. The third one is not here, ML and GWiz. I'm going to show it tomorrow. This is the cowiz dashboard. Well, it's a little bit slow depending upon the network speed. It was much faster. Okay. So these are the 2 different category 1 and category 2 visualizations. These are the feeds. So it's still coming. You can see that these are feeds from December 19, 2025. When did everything become? So this is now not related to COVID, but when COVID was happening, we would filter it using. So this is still happening in real time. These are tweets that were New York Times COVID updates that we are getting in real time. So let us try this. This is animated timeline. So if you click on this, what's it? Well, it's not doing anything. I don't know why. Let me refresh it. So in this one, you can either compare things or look at things for India or USA or for the world. Let us do the world, that is more interesting. So you can select up to 5 countries. So let us pick just 2 for the time being. Let's say India and USA. Do you want any other country? Any country of interest?
Switzerland.
Give me the name.
Switzerland.
Huh?
Switzerland.
New Zealand. Okay. Let's take a look at, I don't think I've seen, played with New Zealand a lot, but it is here. We have all the countries. Okay, you can go up to 5, but 3 is good enough. Then you can choose from a set of characteristics that you want to compare. I usually do normalized cases because that is independent of the population. Otherwise it will be lopsided. So if you want total deaths per million, then it will compare that with, and it will show 2 things. And what else do you want to choose? People fully vaccinated. Okay. Now it will show you that information starting from October 2020 all the way to, see, you can see here, fully vaccinated is low or 0, whereas total deaths, you can see that the total deaths for India is low, for United States is high, New Zealand, it is somewhere, it is along with the x-axis, I think.
Along the axis.
So now you can see that fully vaccinated is increasing for United States. Around March 2021, April 2021, but total number of deaths is still very high. I think there may not be any data for New Zealand. It is not showing up. I had not played with it. So you can see this for the entirety of the data set we have, which goes all the way to May 2022. After that, data stopped coming. So you can play with this. This is live. This is happening as we show. You can go to this website and play with it and see what is happening. Okay? So this is one demo. Let's do the other one, which is more interesting. So this one is the one I showed you. You have to, I looked at something and I had, because there are lots of choices and you have to keep playing with it. So I tried doing 2 different sets. Let me try that and see. So let's say, what is the interval? You can choose this interval from 1 to 30 days, 1 month interval. I have chosen 10 days, you can choose 8 days, 4 days, whatever it is. And you have to choose the base period. So the problem is, since we stopped working on it, we have not fixed the calendar. So it still shows the today's date. So I have to go back. I have to go back to the COVID time. Well, I can't do much about that. So I have here 2021 October 10th is one, October 10th. So that goes from October 10th to October 19th. And then this one will go with some break in between. So the purpose of this break is there is no holiday in between this break. If somebody knows how to fix this easily, let me know. And here I have chosen October. So, okay. So you can see that the first one is from 10 to 19, and there is a 10-day gap or 11-day gap. And the second period is from 31st to November. Now, severity rate, you can choose which one you want to look at. You can either say big dip, or spike, or uptick, or downtick, decrease, or increase, or flat. Usually I give all, because then you will see all of them. And then you say submit. And wait, this is very fast. So this is how, so the change from first period to second period is like that. So you can see that this change is not, I mean, lot of greens. That's important to see, some reds and a lot of greens. Okay? Now let us take a scenario where there is a holiday in between. So just to show you the contrast, let me do the following. How do I need to duplicate this slide. So that later we can see this one and this one side by side. And this one is also 10 days, but it starts from November 10th. Now, September, October, November 10th. 10 days. This one, unfortunately, it resets it when you change one of them. So I have to. December 3. So you see that between 19th November and December 3, there is Thanksgiving. So the expectation is that the change is quite high. So this is the first one. So in this one, it doesn't show. It shows things, but see, it shows in a different region. See here, all of this is green. Here, this is red. What it means is, over the holidays, this region got affected. People in this region did this, whereas people in this region did not do that. That's why, so more red on the west side, more green on the east side, more red on the east side, more green on the left side. So you can go and play with it whenever you want, to whatever parameters you want to give. Give me some feedback. If something is not working, tell me. I want to fix this calendar to stop at May 2022, so that it's easy to play with. Now it keeps going. So if any of you easily know, we use Flask, we use Django. So we use a tech stack, which for all these purposes, we also use Google Maps and various other things. So it is not an easy thing. It's a lot of work to make it presentable, not just do for one short thing. So this is live, it's on our website, anybody can go and play with it. You can see that Alaska, is this Hawaii? No, this is how Alaska is not affected. See, Alaska was affected here, Alaska is not affected here. So you can immediately see where the changes are happening. So I'm going to stop here today. I hope this gives you a different understanding of applying analysis to data sets, different kinds of data, descriptive data, prescriptive data, visualization. I think visualization, it was not easy to get it, because now you see, if I hover over a period, it says Harding County, South Dakota, change percentage 200, population density square mile 0.5, median household income 55,017, high school graduates 32.9%. Similarly, if you go here and look at another one here, Volusia County in Florida, change percentage is 18.32, population density median. So this is very important to understand the context and the details of what you do. Unfortunately, this does not work on phones very clearly because of the layout and the size of the screen. We were trying to do that, but then COVID data stopped, and then we also stopped working on it. So I hope this gives you a different perspective on what data analysis is and how easy or difficult it is to go from raw data to this kind of presentation, which is absolutely essential for analysis, not numbers. Okay? See you tomorrow.
Thank you so much, sir.